if your company gets hacked, now the hackers have a hashed password list. Okay? So you stored the hashes, right? So they're going to have this big, huge list that has username and then a hashed password. They need to guess the password by what we call brute force. Okay? We need to guess these passwords by brute force. And now what we're going to do is we have this huge long list that has people's email addresses and passwords. And what we want to do is guess their passwords so we can use these passwords at other websites. So, okay, I hacked you on Yahoo, and now I'm going to go hack your eBay account and sell stuff there. I'm going to hack your Facebook account and post spam on your feed, various things. But I want your password. I have to do it by brute force. That means I pick a password, so I'm the hacker. So I pick a candidate password, and then I hash it, and then I compare to the stored value. Does that make sense? So remember the server over here, where is the server? Server's right here. Remember the server only stores the password hashed. It never stores, it stores the hash of the password. It didn't store the plain text. And so if I want the original password, I guess what I think the password would be, I hash it and then compare it to the stored value, right? Now, the hackers have computers. You understand that, right? What they do is they use password lists. Okay, I told you about Rockstar that got hacked. So they took the Rockstar passwords, it was some million passwords, and in there they see what people's common passwords are. Okay, so any password that has ever been used in a website that has been hacked is going to be on one of these lists. You guys following me here? So if I was a member of the Rockstar thing and they hacked my password, then I'm hacked, right? I need to change my password. Also, though, if I use any password that someone else used on one of these lists, because what happens, it limits, by using these password lists, it limits the number of guesses to make. Okay? So these password lists, there might be, 500,000 different passwords on here. They can go through the 500,000 lists, hash it, and compare it to what was stored. And this kind of thing only takes, an hour or so. All of them. Every password. Okay? So, you guys you've been to places where it's time to set like your Midas password and they'll say like complexity. Those are annoying.
Theirs is particularly bad.
Theirs is really bad. So the old defense, and this is what ODU is using right now, is we need a minimum length. We need to add numbers. Punctuation. And then upper and lower case. Okay? Those are all good things that add to the complexity. In the old days, they did not have password lists. Okay? In the old days, a hacker used a dictionary. Where's the dictionary? Not in the dictionary. In the old days, the hackers would use a dictionary, and then that would be their password list. But they would hack all these people, and they would end up with there'd be like 25% of the passwords left. And because things like QWERTY is not in the password list, because it's not in the dictionary. So when they started getting these clear text password lists, that really helped them out. Because they got to see people's really sucky passwords, like 1, 2, 3, 4, 5, all that stuff, okay? And where people were taking dictionary words and putting two together, super dog or whatever. So again, the the hacker lists are really long, and yeah. So the one that ODU is doing right now is kind of an old school defense. They want to make it complex, and these are all good things, but they don't actually help if you still put a password that's in one of these lists, okay? And you all know I'm not going to tell you my tricks for getting the more or less the same password into Midas every time, but you can do it, right? No, you guys do new and fresh passwords every time, don't you? Every 180 days. Oh, you guys know, by the way, the server is only hashing it, right? And it'll tell things like it's not. Anyway, just remember the server doesn't actually know what your password was. It only knows the hash of what your last password was. So just keep that in mind as you create your new password. So there you go. They're trying to make it more complicated, when what they really should do is say, yes, we need sort of this complexity. It also needs to be, long. It needs to be long, it needs to be complex, but we shouldn't be checking the dictionary. And that the thing where they make you, other ears listening, the things where they make you include certain items of punctuation, you're supposed to put the % sign in, isn't it, or the ampersand? That's negative on security, right? Because now the hacker knows if it's an ODU password, it has to have this in it. And now that's part of my guessing scheme, right? That's really stupid. So what they should do is look at the password list and say, is it in a password list? And then look at the complexity and then go with from there. So that's the old defense, by the way. So we put all these minimum lengths in. Now, this ends up being not so hard to hack anymore, because the next problem is there are lists of hashes all over, okay? So it is, you type in a hash, and there are hashes like MD5, SHA1, and it will return the text that created it. It's not really clear text, just a note here. Remember, it's destructive, right? So you would type in like this, and then it would say, you can create that by typing New Hampshire. Does that make sense? It doesn't necessarily mean that was what it was. Because remember, somewhere up here, it's possible to have them do, never mind. Let's go with this. It returns the clear text, okay? So this is actually really common, these other lists, okay? The current best practices. I'm going to tell you the current best practices, and then you're going to go out and tell your company that they're doing it wrong is all. You're not going to say, I know how to do it, okay? This is still professionals. The current best practices now, number one is we use multiple iterations, okay? So we might use 100, okay? So if I'm using SHA1, I might do it 100 times. That way, when they're trying to hack my password, it takes longer to crack. We'll just put crack, okay? If they're trying to crack my password, they're going to have to do their hash 100 times, and it takes 100 times as long. Are we good there? So what I do in my customer table is there's going to be a password field, and then I'm going to have like an iterations field. And so the password is all that nonsense. So that's my hash. And over here I have the number of times I put it in. The cool thing about storing it in the customer table is, if you decide 50 isn't enough and you need to go to 100, this time when they log in, you know they type their password and you iterate it 50 times. Then you want to change it to 100, you just do 100 iterations this time and then you change it. You guys can worry about that later. Anyway, you can change the number of iterations. I can't tell you too much or you will go and try to do this, so don't try and do it. But it's possible to do how many times they did it. The next thing is to use what's called a salt. This is an application. The person that designs the coding in the application, yeah. So the authentication code is what does this. So where were we? I've lost all track of my stuff. There's my hacked customer list one. It was right here. Okay. This process here where the challenge and the response, that's the code on your server when you're saying, okay, log in and verifying it. Okay. Just to note, it's not so simple as look up their username and password in the database. You can't do something that simple. What would you say? Yeah. Hmm? Yeah, it's basically an application on the server. If you have, this is like if you're a web application, you have coded it. If this is, Microsoft logging in, Microsoft coded this, and they're doing hopefully something similar like this, okay? So, number one, that's your first thing to do. The second one is to use a salt. A salt is a unique random value that is appended to the password you append it to the password hash and then you hash again. Okay? So what actually happens here is here I have a password that has been hashed 50 times, right? For a salted password, I'm still going to have my iterations. This gets crazy. And then I also store the salt. So if I'm the hacker, if I have your hashed, where am I at? If I have your hash that I stole, oh, this one, in order to get your original password, I have to take your password, or I take my guess, I hash it once, depends on my algorithm here, I usually hash it once, append the salt to it, and then I hash it 50 times and see if it matches here. This is fun, right? Do the next one, guess, hash, salt, 50 times again. Guess, hash, add the salt 50 times again. And so I have to, in order to guess just one password, I have to do my whole password list on one record. Up here, to guess a password, I only have to do my password on the whole list. So I only have to go through the whole list once. I have to go through the password list for every record. This is with salt. I have to go through the password list for the whole table if I haven't salted. This is a little advanced and it's not going to be a specific question on the exam, but I just want to get your heads around, like, in our old original one, where's our original one? In this old one, when they had only hashed it one time and stored that hash on the server, that is super easy to crack. Because all they have to do is go through their dictionary list, hash them, and then compare it to what's in the table, and then just match up whichever ones match your table. And those are all cracked now. The same thing would happen here if I did it 50 times. They go through their list, they hash all their passwords on their list 50 times, and then they compare it to what's stored over here. And then they see which ones are on their list, and now they have those passwords. But down here, they have to go through their whole list for one, to get one customer. Yeah. Mhm. Oh, yeah. Yeah, why does your bank do that? We'll talk about the bank, what the bank's doing, I guess, right now. I guess wrong iteration. Oh, yes, on this iterations thing. Normally, you kind of keep these as secret. I mean, the iterations is stored in the table. You have to store it, and the salt is stored there too. You would keep it a secret in your code whether you're, doing the password first, and then adding the salt, and then iterating 50 times. If you're iterating the password 50 times, then adding the salt, and then hashing, I mean, that sort of complicated thing, or how you're doing it there, is for them to figure out. This up here is for them to figure out too. In fact, all of it's for them to figure out. The thing is, they can figure it out usually, because they might have an account on your server. So they would type in their own password, they know what that is, and then they would go through and find their record and see, how do I get this to hack in, okay? Yeah, and then for, what is it? Yeah, and as far as, if they did it 100 times, and this one was only 50, they would miss, right? Because every time you hash, it comes up with a completely different value. So they have to do it exactly the right number of times to be able to match right here. But the thing is, like I said, a lot of the hackers actually know what the process was. Like LinkedIn got hacked, and they got a hold of hashed passwords, and it was a pretty simple scheme, like one of these where it was only one iteration. And that was the one where you could go to a website, because they had released the passwords. That was nice. You go to a website and like type in your password, and they tell you if it was on the list, and it was like, oh shoot, I'm screwed. But the nice thing about that website actually is, if you want to think of a new password, you can type it in and see if it's on the lists. So there's some websites that do that too. Anyway, salt again is at the high end of the current sort of best practice. But this multiple iterations is good too. If it's only a one iteration, some of these hashes don't really take very long to run. You want them to take a long time to run,